It's day 2 of quarantine for the COVID-19 virus. You are to be working on AMI day 3 if you attend Lamar High School in Lamar, Arkansas. In your physical science classroom, your day 3 is going to consist of identifying controls and experimental values. It's pretty self-explanatory. Real quick before we go on, let's look at the website just to double check you, make sure that you know where to go. Some of y'all should have your packets at home. If you don't, you can go to the lamarwarriors.org website, scroll down to the left-hand side. I know looks a little bit different on your phones. Just make sure that you push the little 3, there's like a little square at the top right-hand side of your phone, and if you push those 3 little lines, it'll take you straight to where you need to go. But let's look here real quick, and we're going to go down to where it says AMI packets. Click on AMI packets. It's going to bring up this pretty little sign again to us. High school AMI packets. From there, here's that sign again. Hey, it's letting you know we are closed. Go down to Science AMI. You can find all your other classes. If you are in the 9th grade or if you are in the 10th grade and you are taking physical science right now, you need to click on Physical Science days 2 through 6. And it brings up a PDF file. We are on day 3. So you're going to complete the 3.2 Identifying Control and Experimental Variables page and answer the 4 questions. This is worth 16 points. So I'm going to scroll down, and there it is. It even says day 3 at the top. If you do not have a way to print this off, it's not a big deal. If you can just read it on your phone, that's great. You can use a separate piece of paper to write your answers. I'm not going to judge you on what you write it on. Just please make sure that piece of paper is clean. So first thing you do, it says at the very top, read. It says an experiment in a situation set up to investigate relationships between variables. In a simple ideal experiment, only one variable is changed at a time. You can assume that changes you see in other variables are caused by the one variable you changed. The variable you change is called the experimental variable. Now we break those up into independent and dependent variables. This is usually the variable that you can freely manipulate or change. For example, if you want to know if the mass of a toy car affects its speed down a ramp, the experimental variable is the car's mass. You can add cargo to change the mass of a car. We already actually did that in class where we changed and added different marbles. The variables that you keep the same are called the control variables, or what we call the constants or the controls. In the toy car experiment, control variables include the angle of the ramp, photo gate positions, and release techniques. So those are all 3 things that stay the same. You do not change those. So then it says we'll use the skill sheet to practice identifying control and experimental values. So it gives you an example to go off of. Alex is studying the effect of sunlight on plant growth. His hypothesis is that plants that are exposed to sunlight will grow better than plants that are not exposed to sunlight. In order to test his hypothesis, he follows the following procedures. He obtains 2 of the same type of plant, puts them in identical pots with potting soil from the same bag. Then he puts one plant in the sunlight and the other in the dark room. He waters the plants with 200 ml of water every other day for 2 weeks. Guys, this is an awesome work to do today because this is actually going to get you ready for the ACT Aspire, which remember I said we're taking April 9th and 10th. And there will be questions like this that ask you to identify the variables and the controls and the constants and the independent and dependent, and to look at the hypothesis or how you could write a hypothesis based off of an example they give you. And so it says the solution. So we're looking for the experimental value, which is what you change or manipulate, and then you can look for up to 3 things that are constants or that are going to stay the same. So we know it tells us that he puts them in identical pots. That stays the same. He uses potting soil from the same bag. That stays the same. Oh, and the same type of plants. So those 3 things have to be the constant because that is what is not changing. But it says that he then puts them one in sunlight and one in a dark room. That's our experimental value or your variables. That's the thing that you're changing. And you can even go a little bit deeper if you want to and say to yourself, well, changing of the rooms and the light, or not the rooms, but the light, that must be the dependent, because the dependent is what you change. The independent is what changes because of the dependent. Listen, Miss Little just said this all backwards. Erase. Back it on up. The independent stands alone, and that's what I've taught you. The independent, that is what you change. That is what you manipulate. Remember I said, if I myself am the independent and my children depend upon me, if I make a change in life because I, the independent, make the change, they must, the dependents, change because I change. So in this one, the independent or the experimental variable must be the sunlight and the dark room, because the independent changes, what you change was the amount of light. It's going to grow depending upon how much light. So let's check our solution. It says the experimental variable in the experiment is the light exposure of the plant. One plant is put in sunlight and the other is put in darkness. The control variable are the type of plant, the pot, the soil, amount of water, and the time of the experiment. So I missed those last two. So then for practice, you are to complete it's just 4 examples. I know it looks like a lot, but this gives you the background information, and then this tells you the procedures. So once you read through the procedures, you read the background information, you then tell yourself what is being changed. What is the scientist changing? And then what stays the same? So let's do number 1 together. It says Julie sees commercials for antibacterial products that claim to kill almost all the bacteria in the area that has been treated with the product. Julie asks, how effective is antibacterial cleaner in preventing the growth of bacteria? She sets up an experiment in order to study the effectiveness of antibacterial products. Julie hypothesizes that the antibacterial soap will prevent bacterial growth in her experiment. She follows the following procedure. Hey, let's stop here real quick. These are some good things that we can look at when you guys come back from our quarantine from COVID-19 or COVID-19. And we can actually say, there's the problem. She stated her problem, her hypothesis. We can even say what kind of materials would she need. And then her procedures are already set before us. It says, first thing she does is obtain 2 Petri dishes with nutrient agar. She then rubs a cotton swab along the surface of a desk at school, then carefully rubs the nutrient agar with the cotton swab without breaking the gel. Has she changed anything yet? No. Repeat the same process with the other Petri dish. Remember, she had 2 Petri dishes. Spray 1 of the Petri dishes with an antibacterial kitchen spray. That is something she has changed. Carefully tape shut both of the Petri dishes and place them in the incubator. Check the Petri dishes and record the results once a day for 1 week. Well, there you go. Okay, so we look back and we say, what did she change? If she changed something, that must be the experimental variable. And we can see in D that she changed 1 of the Petri dishes by spraying with antibacterial kitchen sprays. The other one stayed the same. So what did she do the same on both of them? So that is your control. So it says that she kept the nutrient agar the same. She didn't add anything to the nutrient agar, so that can be a control. It also said that she swabbed an area of the desk. She didn't change where the desk was swabbed. She used a cotton swab. Which, did she change anything on a cotton swab? She could have. She could have changed the color of the cotton swab. She could have changed something, but she didn't. She kept it the same. And then at the end, it says that she put it in an incubator, the same incubator. So it means it probably was set at the same temperature. So you could actually find up to 4 different controls that Julie used to look at. We could even break these down into constants and controls later if we wanted to. We would possibly look at that when you come back to school the week before April 9th and 10th or March 30th. Hopefully I'll come back. So now really, if you did this with me, you've done number 1 with me, and you've automatically gotten your points for number 1 because it's 4 points per question. Now all you're up to doing is number 2, number 3, and number 4 on your own. Little fair warning. For tomorrow's day 4 and day 5, you need to ask your parents on their way home from work, or if you can stop at the Dollar General or walk to Dollar General, but you need to get an Alka-Seltzer tablet. because you're going to be, oh, and I put this in here for people who didn't have paper at home. You can use that to write your answers on. But tomorrow is a lab activity where you can use an Alka-Seltzer tablet. That's what effervescent tablet is. You can use a paper cup or a glass cup at home. It doesn't really matter. And then you need about a 1/4 cup of water. This is a lab that's easily done at home. If you do not have an Alka-Seltzer tablet, tomorrow we're going to look at a YouTube video. I will show you possibilities for that. Or I will even bring my own Alka-Seltzer tablet and have you do your experiment with me tomorrow. So remember, if you have any questions about today's lesson, please make sure that you call me. My phone number is at the very front of this packet. If you go back to the very top, first page, I'm not trying to be a recluse or stay away from you. If you call me, which I did have a student call me yesterday, you can get a hold of me easily. Remember, it's between 7:45 to 3:15. I am not obligated to answer questions at 3:15, but you know me, I'm going to answer them. So, okay, stay safe, wash your hands. Remember today, starting at 11 o'clock, the school is giving out free lunches every day today till Friday from 11 to 1. Students must be in the vehicle with the parent when you come to get the lunches. That's all I know to say. I miss you guys. I really wish that you were here this week. In my heart of hearts, I really do like seeing you. Y'all put a smile on my face. If you just want to shoot me a message and say, Miss Little, it's good to hear from you. I can't wait to see you again. I don't mind to say, hey, how are things going? I will have this posted on YouTube. I will have it on my Facebook. Hopefully put a link on my Instagram. So hopefully you guys will get to see it. I love you all. Be careful. Oh, you know what? Today would be a good day for you guys to maybe go sweep the front porch for your mom or the back porch. But if you don't have a front porch or a back porch, sweep the kitchen. Maybe vacuum the living room, the hallway, your own bedroom, your mom's bedroom. And while they're at work, it would be nice for them to come home to something clean to show that you're doing something to help them out. You are an important factor to their home, and that'll put a good smile on their face. So love you all. Be careful. Safe. See you tomorrow.